So it is January 11th. We are testing out the circuit, the zero cross circuit for the cheap AC controller. And this probably doesn't excite anyone. It's just a breadboard with some components. I'll show you the circuit here in a second. So the included, or the circuit that I started with is here. I put some terminal numbers on it and redrew it a couple of times, trying to get to the simplest node list where you have points connected with various components. And this is what I ended up with. All of the components are identified. There's a list of them, and then as I wired them, I colored them with a highlighter to make sure I didn't miss any. Speaking of missing any, I just added that one. I guess I should put it in there. And we're about to turn the scope on with the leads, turn on the AC, and see what we can see. So we are taking the 120 volts AC off of these two connections here, which are going to the solid state relay. I've added a 12 volt source that's going to plus and minus on the breadboard. And then I'm measuring the voltage across the capacitor, which is capacitor C1. That's on the discharge or the output side of the transistor, which is in there. So I went through and got everything tied together. I've actually got an LED in here instead of the resistor or the jumper that goes from negative to pin number 4 on the chip, on the optocoupler. So we'll turn it on. Beforehand I turned on the source with a limiting resistor and verified that the diode is in correctly and does actually work. So here we will plug the thing in and see what we can see. Okay, I had been playing around a little bit with the scope, so it's on differential, I guess, adding channel A plus channel B, and I had the channel B inverted so that it would subtract them. Adding them is a very large voltage, but subtracting them, basically we get a little square wave across the capacitor, which is a little confusing. At the 2 volts per division, we are showing an approximately 1 volt square wave with a little bit of distortion. I was expecting it to be a little higher because the diode or the diode on the LED is about 0.6 or 0.7 volts, and it's not lit up yet. And that's coming from the positive diode side of the optocoupler. So the 120 volt side is where the diode is being fed on the optocoupler, and then the transistor part is where this resistor and this diode are connected, just to show us what the results are. What I'm expecting is a flicker at about 120 hertz. And that's not what I'm seeing. So what you're seeing on the screen at 2 volts per division is a 2, 4, 5 volt distorted square wave. And right now I'm going across the 2 resistors, which are on the front end of the circuit, which is so that's neutral, and that's hot after the 22K resistors, sorry, 220K resistors. So we'll check the signal on the other side. So there's the 120 volts, 60 hertz wave, which is what you see coming into the system. Okay, we've now moved to the other side of the resistor, and things look a little bit more normal right now. We're not seeing that goofy square wave. So with the 120 volt 60 hertz wave, I think things are back to normal. I think I got to check things that are are pushed in and they're nice and tight. And I smell something. It smells like hot plastic, so I think I'm going to abort here. So since I haven't identified which component it is that's hot, I have turned it off. I do not have a obvious warm temperature on any of these. The resistors are horribly overrated. The diodes are overrated. So I'm not sure what's going on here, but in any case, I'm going to take the system apart, and I'll verify that with the diode bridge that I've got, I get a series of pulses, and then at that point I will check the optocoupler, make sure it's still working, check the capacitor, make sure it hasn't blown, and put the system back together and try again.